The first of the Programming for the Planet 2025 edition. I'm Jean-Michel will be speaking for GeoBond Network. And the topic of the presentation is Programming Opportunities for the Global Biodiversity Network. We will first dive quickly into the GeoBond network and the platform's purpose, but then the presentation will be focused on the IT aspects of Bond in a Box. GeoBond is an important network of practitioners that monitor biodiversity, and an independent one. It ranges from people cutting through the wilderness to others doing ecological modeling on supercomputers. This network has created essential biodiversity and essential service variables, as well as some adopted biodiversity indicators. To contrast these terms that we'll be using a bit in the presentation, the EBVs are by and for scientists. They assess the biodiversity status. Indicators on their end are by scientists as well, but for decision-making purpose. They track change towards an adopted target. Note that some EBVs are the basis for indicators. While EBVs are about standardization and comparison, indicators are about synthesis and interpretation. Then they flow into reporting to conventions that make the object of some political consensus. For example, the Kunming Biodiversity Framework has a monitoring framework that was adopted by countries in a historic multilateral agreement. A myriad of indicators were adopted, some of which we don't really know how to calculate. Others, only one lab in the world can do it. And for others, it's fairly simple. How is a country supposed to be able to report on all this? This is why we need to coordinate, not just locally, but globally. We're not speaking here of federating all the networks into one entity to rule them all. The countries want to own their reporting process. The GBIOS, Global Biodiversity Observation System, would rather be a network of networks, sharing knowledge, standards, and best practices, and helping each other out. It does not exist formally yet, but we strive for it and are inspired by the GCOS of the climate realm. I encourage you to read the Gonzalez paper for more details. This system needs a way to share analytics, and we provide a way to do it. A software to integrate biodiversity data and model that we call the Bond-in-a-Box pipeline engine. Bond-in-a-Box was an existing platform in which we added this calculation module to calculate essential biodiversity variables, indicators, all this based on a curated open source repository of community contributed analysis pipelines. So the GeoBond community in that case, but also larger. It feeds on local and global data sources. So if we look at this biodiversity data transformation chain, we're rather at the top of the pyramid, EBVs, indicators, reporting. The data and taking care of the reality and the data is done by some of them GeoBond members, but done by others. For example, take the Colombia example we have here. Colombia knows how to transfer their data into a specific indicator, whichever one. If they make the effort to generalize and contribute their expertise to Bond-in-a-Box in the form of a pipeline, other scientists that understand the theory or would take months to rewrite the workflow now have access to it. This same thing needs to be calculated in every country, as per the convention. Another party could use this in Bond-in-a-Box with local adaptations if needed. It's a huge accelerator for the global biodiversity framework. And you can see the pipeline schematic on the right side. It's our next topic. The base unit of these pipelines are scripts. Here, you're familiar with scripts, I'm sure. It's our base unit, a single step that does one thing, transforming inputs into valuable outputs. And this cohesiveness empowers modularity within the pipelines. To integrate a script into Bond in a box, you simply need a description file and reading the inputs and outputs thing to the system. So it's fairly the same script that has been being used outside with modifications to ensure input validity and the sort. And the YML description file generates a form for the script that you can see on the right side. These scripts are assembled into pipelines, and this is what we call syntactic interoperability. The file is the only link between the steps. So a step could be an entire subpipeline or even run remotely. And this is why I say that interoperability is freedom within. As long as you are standard on the interfaces, in this case, the files, inside you can do whatever you want. Well, to the limits of scientific validity, of course. This is what a pipeline looks like in our UI editor, each of these boxes being backed by a description file and a script. And there are tabs to edit the metadata on the right. So every input that is not satisfied will end up in the same kind of form that you have seen previously for the scripts. And you can enter author, citation, metadata as well. The metadata and the missing input generate this form, and we can view the results in our visualizer that we call the results viewer. We have a more detailed view also that we can access all the intermediate results, logs, and code for full transparency, a bit less aesthetic, but for the sake of transparency, it's very important. And this leads me to the founding principles of the pipeline engine, out of which transparency is one. So all the intermediate results must be visible, the source code, the references, nothing hidden. For the pipeline itself and for the run of the pipeline as well. The code and platform are open source. The scripts can be reused in many pipelines, and we enhance reproducibility since it's easy to rerun the pipeline with the same parameters or change the years and run for updated results. This is the founding principles of the pipeline engine. This is backed by a microservice infrastructure that can be ran on laptops or on servers. This is why it's important for data sovereignty that with the Docker Compose technology, we can easily run it on a server that would be internal to a country. They could be managing the access, and we're not responsible for handling their sensitive data. They are. So we're not being a data holder or a data provider. We can do it, but in event there is sensitive data, we really recommend the countries to handle it themselves. We can connect to any data sources that you can write a script for. And we will soon release a version where we can run jobs on an HPC over Slurm using Aptainer containers. So I stop here for questions one first time, then I'll dig into specific questions about IT science, and you'll have the chance to comment on those as well. All right, so I guess the video has been resumed. I can now ask my own questions. So feel free to do suggestions to give contacts, partners that could help. Some of these programming opportunities are things that are very remote, some are closer. And I'll walk you through them and the stakes. For example, the peer review. We have a peer review process, a bit like you have for papers, to make sure that the code meets the community standards, meets the documentation standards, and actually implements the scientific methods they claim to. So we want at least 3 reviewers. There's a formal form they have to fill. And once this is done, the pipeline is vetted, we change the label from in review to peer reviewed, and it can be used more safely. But we could freeze, for example, all the dependencies with conda. But with multiple versions on the same package on the same platform, it would be heavy for an ordinary computer. And we want this to be able to run on ordinary computers and on servers with limited capacity, as well as big servers for heavy calculations. So we don't want to freeze all the dependencies. But if the dependencies change, what happens? Do we need to re-review to make sure it didn't break anything? Or if we find a bug in the pipeline and we resolve the bug in the pipeline, do we re-review again? We might do static tests. Okay, these inputs should give these outputs. But they might miss a particular situation, or also we can only perform so many static tests because these are intensive computations, so we don't want to retest so many different scenarios every time there's a small change. So my question here is, can we detect if the change either to resolve a bug or to a change in dependencies has a major impact on the execution flow? Can we have a hint about what should be retested and what does not need to be retested? Easier if it's a bug that was resolved, harder if it's a dependency change. I could imagine something like this function graph here, where the percentage of modification for each function could be written in line on the script, or maybe conditions of the change. Well, this will be affected only if this parameter is true, or a visualization of the call tree, and then we see the differences and can try to backtrack to the main script and see if there's any effect. That's a bit heavier. Of course, the second proposition here is really interesting because it's the less work to do, but it's probably the harder to program. So I'm wondering if something exists already or is near to exist that could perform these tasks. Stop here for your input. The next one is the data visualization. So the inputs and the outputs are as varied as you can imagine. We get all sorts of inputs, geospatial, occurrence data, and shapes, and we output so many things as well. And we get along well with a few standard types, but there are questions. Could I manually clean occurrences live between two steps? Do you support interactive graphs as outputs? Or this specific data format? So my question here is, could we plug in data visualization decided by the pipeline contributor, but for which we are not the maintainers? For example, could we use WebAssembly to spawn a QGIS for data addition and then take the results and continue the pipeline? But in a way where we don't have to do specific things in our backend and our front end for each of these platforms. Maybe there's a library or somewhere that allows to plug these things more easily. So this is where I will listen to your feedback. The next topic is the chains of trust. This is a forward-looking one. Currently, bound-in-a-box instances don't communicate with each other, so this is for the future. Take an endangered species, for example. At the occurrence level on the left side, there is a risk of poaching if the data leaks. Once modeled, it's a lot less sensitive, but could still be considered so by local authorities. Someone could look at the map, oh, there could be this species in that region. But once aggregated into indicators, there is no risk for the species. How much different species are there in a specific location in that example doesn't tell you if you could go poaching for one specific species. So if we have data flow from the data source through box nodes to an aggregated version to the CBD, well, there are some parts that are sensitive. What technologies should be used to build these chains of trust, ensuring that permission level required to access the result lives in the metadata, and if possible, evolves with the level of aggregation. For example, we don't want to block the whole box instance, but maybe only viewing some products based on the level of sensitivity of the data. And again, I'm listening to your suggestions here. Finally, the dynamic data flow. Currently, pipelines explicitly support some data sources and uploading some specific user data for some parameters. But in the spirit of maintaining the integrity of the peer-reviewed pipelines, but allowing to integrate multiple, possibly unforeseen data sources, it would help to accept only a standard input in the peer-reviewed core and compose a pipeline by prepending an adaptation layer that converts data into the suitable format for the pipeline. We came across semantic modeling, which would be very elegant to solve this for major global sources, but the learning curve is steep and we cannot afford to teach the syntax to everyone who wants to use it for local data. So then we could also write converters manually and dynamically assemble them. This surely has been done already somewhere, so maybe we could reuse it. So I'm listening here to your suggestions again. Well, thank you very much for listening in. Feel free to contact me at web@geobond.org or to leave your address to Anil, who's in the room. And I'll be delighted to respond to your questions and have a good programming for the Planet conference. Thank you.
So I have two questions. First is, does One in a Box is more like a data space for like biodiversity data? And if that is the case, why don't we use the existing data space and then just do things on top of it? Because I'm pretty sure there are like a bunch of PL techniques that's been using on data space. There's a line of research in that area. And the second is a bit more technical. That is, say we have two different data sources and of data coming from two different temporal or spatial resolutions. How the mismatch, or is in general, how the mismatch in data is detected? So yeah, these are the
Hi, do you hear me correctly? Okay, from my own voice, so I'll mute myself while I speak.
yes.
So the data space. So One in a Box is not data provider. It's a way to transform the data from its original source, whether it's in GBIF or in some spatial temporal assets catalog, into a derived product. So it's really a place where we transform um, the the data into a product that is useful for the biologist or for the decision makers So it's more about transforming the data. And when we speak about fair data, it's a lot in the words these days. Fair data for all this biology data, but we also think of fair processing. Can you find easily how to do the processing? Is it accessible to ordinary biologist? Just these two first questions is probably no in a lot of cases, unfortunately. So these are the sort of things we're trying to address, and same for all the rest of the letters. And then for the data sources, well, the example you used was about spatial temporal resolutions. In this case, we just used the stack catalog technology in with cloud optimized geotiffs, and we query them using GDAL cubes. And with GDAL cubes, you can just on server and download just the right part of the file that you need. This is more on the expertise of some of the people writing the scripts than my own expertise. But that's what they use for harmonizing geospatial data. But when we speak of taxonomy, becomes much more difficult. There are ways to do that also, but it's not Bon in a box providing the solutions. It's people using provided solutions, scripts in Bon in a box.
Great. Last question, anyone? Yeah,
Thank you for the
very
question, by the
quickly.
way.
You talked a bit about kind of potentially change propagation or some kind of detection that, you know, a data source might have changed, or perhaps there's a new revision to a data set, and then kind of propagating that through your pipeline. Is that something you're planning to do, or is something you've already got some kind of infrastructure for?
So just to make sure I understand the question correctly, you mean something that would live update whenever changes? Is that right?
But not specifically live update, but maybe I misunderstood what you mentioned on the slide, but I think you were talking about detecting when inputs have changed and working out which parts of the pipeline might have been invalidated by that change.
Okay, yeah, I was really speaking there of the code behind it. So a problem we that is already arising is that we have our first pipeline that went through peer review, and if the dependencies change, the new results might be incorrect just because of the package updates. And it's really here not the source data that has changed. Again, Bon in a box is more about harmonizing and being fair on the way we transform the data. So in order for this to be reproducible, the same peer-reviewed pipeline has to behave exactly the same way. Of course, we do a dependency dump just to know which dependencies are actually there when the pipeline is peer-reviewed. But then, and we can always revert to exactly these dependencies to be sure. But in that spirit, it's really the dependencies that change, or a bug that was resolved that would do a change in the processing, and this is what detect in order not to either retest the whole thing all the time, which is basically like launching tasks on HPC because you're testing 3,000 species for the whole Canada. Well, that's not convenient, or missing these edge cases. So having an idea what in the code, a hint on what we should retest would really help us.
Yeah, I think I misunderstood what you were talking about. Thank you.
Thank you.
All right, let's start again.